All right, I just am determined not to get out to that football game. Sorry, you guys. So my video cut off on me. Apparently, I'm limited on YouTube. So here, I'm picking up from that first video. So here's the continuation of it. We just have a little bit more to go on this. So if I have parallel and perpendicular lines, so if so what we're going to do is we're going to be a little investigative here. If I would need a line that is parallel to this line, I just need a piece of information out of this line, and I need its slope. So its slope, remember, is what's in front of the x. So this slope is 3. So once I get the slope that I'm looking for, if I want a line that's parallel to it, remember all parallel lines have the same slope, so I just need that 3 out of that line, or out of this piece of information, and I am done with that equation. I can throw it away. All I need is the slope, and then I can discard all the other bits of information from it. So now, just like in the last video, the last problem we did, I now have a slope and I have a point. So I can put that in my point slope form. So y minus y1 equals 3 times x minus 2. x1. So I can clean this up just a little bit. Maybe y plus 1 equals 3, x minus 2. And right now, in the next video, we're going to talk about simplifying this, but right now that's in point slope form. I'm so sorry about that. This is one of the equations of the lines. So once I have it in any one of the 3 for now, unless my instructions say to put it in a different form, you can leave that alone. So if I want a parallel line, so my steps up here, let's talk about our steps, what we did. So the first thing we did was that we identified our slope. Then we're going to determine the slope to use. If I'm talking about parallel, so if I have parallel lines, then I'm going to use the same slope. But if my instructions down here were to say to use this point but find a perpendicular line, which we'll do in our next example, perpendicular slopes have the opposite reciprocal. So for this example, this slope down here was 3 over 1. So the opposite reciprocal, if it were asked for perpendicular, would be negative 1/3. If it's positive, you make it negative. If it's negative, you make it positive. That's what opposite means. It means opposite sign, really, is what we're saying. Take the opposite sign. And then reciprocal just means to flip the fraction upside down. Okay, so once you identify the slope, then you determine what slope you're going to use. And then the last step up here was just use point slope form. And you're done. Okay, so let's do another example. So this one is going to be perpendicular. Oh, where'd my perpendicular one go? Oh, my perpendicular line, sorry. So here's my perpendicular line. So I want a line that goes through this point that's perpendicular to this line. So forget about that point for now. So here I'm just going to gather out of this my slope, so my slope right now is negative 2/3. But my instructions are asking for perpendicular. So the slope I'm going to use is not going to be negative 2/3. It's going to be positive 3 over 2. So we're going to use that 3 over 2 slope. And now I'm done with this. Now I can discard that. All I'm going to do is use this slope and this point and put it in my point slope form. So y minus 3 equals 3/2 x minus 0. And just leave that 0 there for now. We'll talk about cleaning them up in the next video, like I said. So that is in point slope form. Okay, 2 tricky situations I really want you guys to keep an eye out for. Parallel line with an undefined slope. So I want to go through this point. So I want to draw this as a picture. So if I have 2, -8, that point's going to be maybe somewhere down here, right? So 2, -8, and I want a parallel line, or parallel to a line with an undefined slope. So I know my undefined slopes. Are they the horizontal or the vertical ones? They are, nobody's answering me. They are the vertical ones. So these are my vertical lines, right? So I want a line that's parallel to this. You know, these all have undefined slopes, but I want it to go through this point. So there's only one line. Oops. that goes through that point. I so can't draw. So there's only one line that actually goes through this. This is the one and only line that I actually want. I don't need any of these, right? I want the one that goes through that point. So give me the equation of that line. So it's a vertical line, so it's one of our special lines. It's only going to have one variable. And the vertical lines begin with x equal to, so my x value is 2. So x equal to 2. If it had asked for a line with a 0 slope, then it would be y equal to -8. But it asked for the undefined slope, so 2. So x equal to 2. And last tricky one is right here. So again, draw yourself a picture if you need. So 1, -5 maybe is down here. And I want it perpendicular to this line. So the line y equal to 9 might be way up here. Okay, that's right. Y equal to 9, it cuts through the y-axis, so it's a horizontal line. It has a slope of 0. And I want a line that is perpendicular to that line. So aren't all these lines perpendicular? All these lines are perpendicular. But there's only one that I'm interested in, and that happens to be the one and only line that goes through that point. So what point goes through, that goes up and down, again it's a vertical line, that goes through that point that I'm given? Well, that is an x equal to 1. There are different variations on this, but I think after these two examples, I think you hopefully will understand what I'm talking about. All right, going out to the football game.